She's Innovation Director at the Microsoft Research in Cambridge and also appears on some BBC documentaries, Big Life Fix. And yeah, welcome.
Hello. Hi, everybody. So we're so close to lunch, so I'll make this snappy and quick. Hello, I'm Hyann. I'm Director of Innovation at Microsoft Research in Cambridge, in the UK, the original Cambridge, if there's any doubts. And I call myself, well, I'm a designer and an engineer. So I started out in computer science and I moved to being a designer. So I worked at consultancy firm called IDEO for about 7 years, and in the last 5 years I've been in Microsoft running innovation teams in Xbox and in research. And I essentially call myself a maker of things because I think it's a really nice fusion of design and engineering practice to treat technology as a design material and to work with that from day one. So I think that a quote that really encapsulates my philosophy about design is from Eileen Gray, who's a self-taught architect and furniture designer. And she said, to create, one must first question everything. And, you know, this is a really broad statement, but to me, it means just, you know, whether you're designing an interface for an iPhone app or an Android app or a product, you're essentially baking into that design how you think people should go about their day, should live, should have a lamp in their house, the quality of that lamp. And I think, to me, with every single act of design, I think that it's also has the potential to be an action to change the world. So I'm a big fan of knife fights in the design process. So meet me in the dark alley and we'll debate over whose collective narrative, whose narrative of the future will win. Because I think we, you know, within design, within service design, interaction design, we've been talking about these narratives that we all share, things like the sharing economy, things like sustainability, things like open source. And these are, I think, within our culture in Europe and in North America, these are sort of narratives of kind of a science fiction or a design future that we would like to see come to pass. But, you know, just harking back a little bit on my childhood, that was not always the case. So I was born in China in the aftermath of the Cultural Revolution. And in my early years, this is not a picture of me. I did not look like a boy when I was little. In my early years, you know, I went to primary school in China, and at the time in the early 80s, it was very over-indexed on the Communist Party and party philosophy. And so I was in a system that was very much focused on stripping individuals of their personal agency, of opinions that differed from the party. It was kind of like an institutionalized fake news system where every piece of information was filtered through this kind of philosophy, whether or not it was true or not had to be sort of bent to its will. And then transition that to when I moved to Australia. I moved to Australia the year that Star Trek: The Next Generation aired on TV. And it was super kind of, it was a revelation to me to go from this kind of system where individualism was frowned upon to a system where you could, this world where you might be empowered to pursue your own interests and to achieve what you might be great at in the world. And particularly, I was a big fan of Star Trek, and particularly empowered by technology, where technology would serve to enable your personal agency, to allow you the freedom to explore what you were interested in. So I sort of went into technology as a practice, and always thinking about sort of using technology as this kind of design material to change the world. And in recent years, I've been involved in a BBC documentary series called Big Life Fix, which is bringing together about 7 engineers from around the UK, engineers and designers from around the UK, to invent cutting edge technology for people in need, which is really funny because the audience on BBC Two, as we're told, are kind of like grannies in the Midlands. So it's a real juxtaposition. So one of the projects that came out of this show was around sort of supporting a young lady called Emma. And Emma, when she was 28 years old, she was diagnosed with Parkinson's disease, which is actually a very rare event. And as a result of her disease, she had acquired an action tremor in her hand. And she was, being a graphic designer and a creative director, she was no longer able to pursue her job because her hand shook when she was trying to draw wireframes or write her name. And so I worked with her to think about, well, how can we create something that might be able to help her overcome this symptom? How can we fix this problem through a design and an engineering lens? So I'll just quickly show you that video.
Right, I'm going to try and replicate this here. We're off to a great start. I tend to kind of just avoid doing sketching and writing now because it's not really worth it if you get something like that. Anything you could do that would just make my hand do what I want it to do and be able to sign my name would be an incredible thing.
How do we even just begin to help her overcome this particular symptom of her tremors and helping her be able to regain her writing ability, her drawing ability? You know, I don't think we're ever going to get that back 100%. You know, my challenge is I mean, it's immense.
Someone's made a spoon, it actually counteracts the tremors you get from Parkinson's. So the spoon actually vibrates in opposition to how your hand might be shaking, and therefore it is steady.
I'm making a very rough prototype. And what this board does is I can connect into it through these wires, these tiny coin cell motors. So these motors will vibrate. Hello.
Hi, I'm Alison. It's affecting something. I don't quite know what's happening. Something is going on with it.
What this is doing is it's short-circuiting whatever feedback loop there is between the brain and the hand that's causing the tremors. I'm on to something, right? I'm on to something.
Woo! Woo! Jesus Christ.
Oh my God.
It makes me forget that I have a tremor. I haven't drawn one of them for a long time. I'm so casual about it. Yeah, I'm just going to draw a straight line. I've actually just written my name for like the first time in ages.
I can't believe it.
Mum, it's called the Emma.
Oh, brilliant.
It's got my name on it.
Thanks so much. Thank you. Yeah, so I think, I mean, one of the takeaways that I have from doing this work, and there are many, one of them is that I think that you can't quite tell if this is a design project or an engineering project, because design alone couldn't solve this problem. But at the same time, I think I mean, the clip didn't show it, but my undertaking was a design process, and it was the design process that led me to the insight to start prototyping with this kind of intervention. And so an engineering process on its own could not have achieved this either. I think the other takeaway, which I will talk about in a bit, is just that there is so much potential for technology in all its forms and in its physical form factors to still have relevance and make a huge impact that we haven't explored yet. And I know today we've been talking about algorithms, we've been talking about smart systems, but my focus and passion for, I guess, the last 10 years has been about hardware and devices. And I think it's through opening up new form factors, new inputs, new outputs, that we're able to create a new stage for where algorithms can come into play beyond mobile phones and the desktop metaphor. So we are with our Microsoft research team, we're continuing on some of the research into this technology. And some of those challenges that we are now encountering are, we really do think that smarter algorithms can make the effect more amplified, but there's this transition, or there's this question between signal processing and machine learning. So where does signal processing end, and where is it better to pick up machine learning as a tool to do this? And we're not quite sure without going through the hard work of implementing each piece of technology to test it out. And so, I mean, I think through some of the discussions that we have around machine learning, there's this kind of idea that machine learning is the solution for everything. And I think we need to really question that and understand sort of where the boundaries of machine learning end, and where we can best leverage other kinds of algorithms, of rule-based algorithms still. So we're continuing to develop some of the study apps and tech to capture this data from more people. I think one of the really interesting things that Emma says herself is that, she is dealing with so much in her life and so much from this disease, and wearing this watch has been able to give her back a little bit of that dignity that I think the disease has taken away. It's not a cure, and it's not fixed everything. But if the technology can give her back a little bit of her agency and her dignity, I think in that itself is a really worthy value for us to pursue. And at the same time, when we think about algorithms in the loop or AI in the loop, by wearing the watch, Emma is able to regain some of the clarity in her writing, but it's not perfect. This is not an augmentation to allow her to write like a robot, to give her perfectly straight lines. There is still a little bit of quiver in her writing, and she enjoys that because the disease is also fused with parts of her personality. So she enjoys the imperfection. And that the technology, through not working perfectly, is actually giving her back some of that personality that she misses. So let me transition into another project that I did recently last year, working with a young girl who, when she was 8 years old, she had a car accident with her family, and she suffered some traumatic brain injury. And she's now 12. And at the time when she had her accident, it was quite devastating, and she could no longer, she couldn't walk, she couldn't talk. But over time, she was able to rehabilitate, and now she's up and about and running around on the playground and going to school. But she's also sustained sort of more long-term issues with her memory. And so I went in to see if we could create technologies to help her regain some of that memory, to help her capture some of that memory. So through the design process, working with her, I was able to kind of start to map out what the challenges were. And memory is kind of like trying to define what memory is, kind of like sand running through your fingers. Everybody said she had short-term memory loss, but actually she didn't have that much short-term memory loss. What she did have was this inability to to remember events or episodic memory in the long term. So if she'd go on a picnic with her family, she could remember it for 30 minutes, but she wouldn't be able to remember it the next weekend. If she took a class, she'd be able to remember things in the class, but she would forget it the next time the class came around. So I really set about sort of trying to think, well, how can we create sort of technology that augments her memory, augments her brain in some ways, not through everything that she's doing, but at specific moments. And these might be different pieces of technology. So thinking about how can we build her knowledge to complete school? How can we help her relive her emotional moments with her family? And I would say that the results are, they're interesting and they do work for her, but at the same time, the physical form factors I still find clunky because I had to use, tablets and off-the-shelf equipment in order to kind of augment some of her daily routines.
Do you remember us arriving?
I remember waking up, but then I don't remember what I did after that.
We went for a family wedding. We just literally remember waking up in hospital. They kind of just said, she's not going to make it. Everything was baby steps. She literally had to learn how to eat again, how to talk, how to walk. It was almost like having a newborn baby.
And then we can perch.
What was the third instruction? Can you remember?
No.
I think we need 2 fixes. One to help her with her classroom so that she's not falling behind the rest of the class, and one to help her with her family memories so that she can just remember her childhood.
The code is killing me.
It's a tablet that sits next to you. So as the teacher is giving the lesson, you'll see the text of what they're saying appear on the screen.
If Miss Powell says something, I can just play it back on this.
Yes. And so if you try it, there you go. And then the other thing you can do is in class, if Miss Powell says something.
First time that you joined in Monopoly.
I don't remember this.
But you still had that smile on your face, Summers.
I remember that. I remember that.
So just to be clear, it works.
Yes, it does.
So, I mean, I think part of that solution, as you saw, was some cognitive services where we turned the teacher's speech into text, and she's able to rewind that in the class to see what happened 5 minutes ago. And I think, these today and also other AI conferences, we talk glowingly about AI and what it's been able to achieve. But I think when the rubber hits the road and we're trying to really make solutions that work for people, there's still a long way to go. This technology, I mean, I think it was a great proof of concept, but at the same time, how did we capture the voice of the teacher? I had to put a lapel mic on her because we couldn't isolate her voice in the classroom. She had a Birmingham accent. I had to train specific models just on her accent. And then the kids in the class had names that weren't, Anglo-Saxon names, and that was difficult to translate. So I think there's still a long way to go. And also in terms of technology form factor, the fact that she has to have this tablet next to her in class is not ideal. And then finally, I'm just going to quickly share some of the work that my team and I have been doing at Microsoft Research for the last couple of years, where we've kind of really looked at, well, how can we open up the space of physical digital exploration? How can we kind of create new theaters, new spaces within which people can interact with computers and kind of create these new kinds of experiences? So this is, we've won a Best Paper Award for CHI 2018, so please come see us if you're in Montreal. And this project really started because we were really obsessed with expressiveness through tangible user interfaces and frustrated with the history of TUIs and how they were fixed in place. They required a lot of setup. There was occlusion issues. And we really wanted to set out to create kind of a more fluid TUI system. And I may be old fashioned, but I freaking love TUIs, man. All right, so and then this is the project that we created. So that's the technical preview, and we've worked with the Microsoft Edge ML team to do onboard sort of machine learning in terms of detecting the different gestures, hover gestures, and at the same time we're thinking more upstream about what are some of the applications that can open up the expressiveness.
I'm hit.
Open up new learning and play opportunities. And here we see much more space for new kinds of algorithms that can enrich these play and learning experiences.
C A R car.
And so we've actually engineered the entire platforms from scratch, because within the team, working in this multidisciplinary team, we really don't see a divide between the design vision and the engineering possibility of this technology. So, you know, I work with a multidisciplinary team of hardware engineers and designers, product designers, computer scientists. And if you are in Montreal, come see us. We'll be giving hands-on demos as well. Thank you.
So we're running a little bit behind, but if there are a couple of questions. Otherwise, if everybody's hungry.
Thank you for the talk. It was very interesting. What interested me about the problem solving for a man was there was this step of, like, you had the little diagram of how memory is divided and then jump to the solution. And I was wondering if you could maybe tell us a little bit more how you came up with the actual design idea that we will relay speech into text and then highlight it in colors, and also the one for the family memories, because that was the very interesting part about it.
I think I'll talk about the family memories because that was very interesting to me as well. So Armin, she can't remember memories with her family. And there is some research around memory loss and using photos to jog someone's memory. And in her case, it didn't work. She could look at photos and she wouldn't remember. But we did a design exercise where we went out for the day and we had her take the photos. And she was punting on a boat in Cambridge, and she thought the punter guy was really attractive. So he looked like somebody from One Direction or something. And so she was giggling the entire time. she was so delighted. And then afterwards we went to a cafe and she was sitting there, she was looking at the photos. And when it came to the picture she'd taken of the punter, she didn't remember him at all. She was like, oh, I don't know this guy. So she'd lost that kind of delight from her memories. But then while she was doing that, her mum sitting next to her just said, oh, Aman, do you remember, this is the guy, he looks like Niall from One Direction. And then this sort of smile came over her face, and she remembered this event through kind of her mum retelling that story of how she felt. And so just for me, through that, seeing that interaction allowed me to kind of create this app where, I mean, it's a very simple app where her family can upload photos and record personal memories for her. And just through this combination of sort of personal stories and images, she's able to recall some of these memories, which is really amazing.
And how long does that recall last? Like, does she have to kind of almost remember, like create that memory every time she looks at it? Or is there some kind of retention of the information?
Well, I think for me, this was a kind of short kind of project to create something. So there hasn't been a more longer term study. And I think every person is very individualized, this kind of trauma as well. I don't know, it's challenging because I talked to neuroscientists who do research into memory, and they talked about how people like Armin may never be able to experience a memory the way that we experience a memory. So they may be able to remember the details, but they may not be able to remember the emotional quality of that details. And I think I feel that through watching her, she is reliving some of that emotional component, and perhaps through regular retrieval, she's able to maybe build those connections in the long term. So
it's very cool. Thank you very much.
Thanks very much.
If there are no more questions, then we can break for lunch. Lunch is over there, and we will be here at the 2:45 sharp to go on with the program.